Hi, this session is Developing and Managing a BI Semantic Model. My name is John Hancock. I'm a lead program manager in the SQL Server Analysis Services team. So before viewing this session, you might want to take a look at the session entitled What's New in Analysis Services and Power Pivot, as that will give you a lot of foundations of what the BI Semantic Model is about and how the technology works. For this session, we're going to be focusing on the steps to actually develop and then manage a BI Semantic Model. So starting with some context to set the stage, the BI Semantic Model is one BI model for all end-user experiences. And what that means is that once you've developed a BI Semantic Model, you can deploy that and then use that in any client tool for BI, including Excel and Power View and scorecarding and custom applications. The BI Semantic Model consists of a data model, a business logic and queries that can get executed against it, and data access to the sources that are behind the model. In SQL Server 2012, with the BI Semantic Model, whether you're working in Power Pivot for Excel and doing personal BI applications, or sharing those with your team in SharePoint, or building full-sized, full-scale corporate BI applications using analysis services, it's the same model that underpins all of those scenarios. For today's session, I'll be focusing on building the model using the organizational BI tools or the professional tools, but the same kinds of modeling can be done using Power Pivot for Excel. So I briefly mentioned there that we have two possibilities for developing models. So this, I'd just like to talk a little about how you choose which one is right for your needs. So for information workers who are comfortable with Excel as a technology, who have rapid response to business problems and very used to the Excel paradigm, they should be using Power Pivot for Excel to build their models. It's a much more familiar environment, and when they want to share that model, they can just publish that up to SharePoint. For BI developers, where they have a project and they need to build a full BI solution, they'll typically be using the BI Development Studio, which is been renamed to be SQL Server Data Tools in SQL Server 2012. It will feel like Visual Studio. You have source code, you have TFS integration, and the experience is much more optimized for a BI developer. So as I said, I'll be focusing on the right-hand side for today's session. So let me spend the rest of today's session just walking you through the process of building these models and switch over to a demo. So the first thing I'll do is show you how someone can actually use a model that has already been built by a professional model builder. So I'll start out as an analyst in Excel, and I'm going to go and connect Excel to an existing analysis services model. I'll just say from other sources, from analysis services, specify the server where this model has been deployed, and then choose the model. So for this example, I'm an analyst in a small police service, and the model that I'm going to be using has a lot of information in it on things like training courses that members of my police service have undertaken. So once I've connected in Excel, I can now do ad hoc analysis. And on the right-hand side, you can see a very rich model that has things like KPIs and measures. It has lots of different dimensions of the data to look at, like training courses and dates. And pretty easily in Excel, I can just go ahead and pick things like the average score, and then the position of the employee who's taken the course, and then things like the employee's full name. So it has a very interactive experience. As you can see, it's very fast, and it's all powered by this BI Semantic Model that I've built. So that was an example of using this in Excel. Let me show you the same experience using Power View. So here I am in SharePoint. I have a reporting services data connection to that same model that I was using in Excel, and now I can go ahead and create a Power View report to do ad hoc reporting and data visualization on top of that model. And as you can see, the model is the same. It's presented differently to Power View users in the sense that it shows a list of tables rather than measures and dimensions as it does in Excel, but it's powered by the same model under the covers. So I can do the same kind of analysis in here. So I can do position and employees. So I can do ad hoc reporting right there in the browser using the Power View tools. Because it's Power View, of course, I can build much more interesting and sophisticated data visualizations. So, for example, I can go start building interactively show the max scores and then start showing column charts and really have a much more interactive and fun way of working with a model to build some great looking data visualizations. Okay, so that's showing you, how end users can actually connect to the model in Excel, in Power View, and in other tools and use that model. So let's switch gears now and show you how I would go and build the model that I've just demonstrated from scratch. So I'm going to go ahead and open up SQL Server Data Tools. And here in SQL Server Data Tools, I can go and create a new project. And under the Business Intelligence folder, there is an Analysis Services section, and we can take a quick look at the choices here for building models. I can choose to build an Analysis Services model either as a multidimensional model or in SQL Server 2012 as a tabular model, which is what we'll be focusing on today. Another important one to call out is that if I already have a Power Pivot model that an information worker has built, I can import that into Visual Studio, into SQL Server Data Tools, and use that as the starting point for a project. In this case, I'm just going to go ahead and do the start from scratch with the tabular project. Now, the first time that you use SQL Server Data Tools after you've installed it on a machine, it's going to prompt you for an Analysis Services instance to use for modeling against. So what this means is that in order to build a model, you actually have to have an Analysis Services instance running in tabular mode in this case, in order to actually even build a model to start with. Many people will install a local instance of Analysis Services on the same machine as their dev server, as their dev machine for this purpose, but you can also have a shared server that multiple developers use with an instance installed on it. And once I've specified this, it goes into the project settings, and then from then on I don't need to re-specify. So here I have created a new BI semantic model project, and it's in Visual Studio Shell, so it supports solutions with multiple projects. What I'm actually working with is source code. So if I go and edit this as code, you can see the XMLA source code that is behind the model, and therefore I can use things like TFS and source control systems to manage this. Let's just go back to the designer. Okay, so the first thing I'm going to do to start off this model is actually connect to my data warehouse and bring in some of the tables that I need. So I'll just say import from data source. One very important feature of the BI semantic model is that it allows you to connect to many, many different data sources, classic relational sources, as well as more interesting sources like Azure Data Market connections, OData, reporting services reports. Can connect to Excel files and text files. So it really allows you to bring together data from many different sources and put them into one model. In this case, I'll just choose SQL Server, and I'm going to connect to my local machine and pick the data warehouse database that I have for this police service. So I'm just going to specify my credentials to connect. And that now gives me a list of tables that are in this data warehouse. I could go and write queries if I'd like, if I to have more control. But in this case, I'm going to go and pick from the tables and views that have already been defined in this data warehouse. So there are a number of different subject areas. I'm going to start with the first one, which is training attendance, which is the model that I showed you from Excel and Power View. So I'll just choose select training attendance, and I know that connected to that fact table there are several dimension tables, so I'll select related tables and go and pull those in as well. Now I happen to know that position is another table I'm interested in, so I can add that too. Okay, so as part of the import process, I can also, if I'd like, rename the tables that will be created in the model. And another important thing that I'll probably do during this import process is filter some of the data. So my fact table in this case may be very large, it may be billions of rows in practice, and while I'm modeling, I don't necessarily want to use that whole data set to model against. So as I'm importing it, I'll just go and filter it so that I'm only bringing in, for example, data from a certain date range. So in my case, let's say it's where the date key is less than 1,000. And now, when I bring in the data to model against, that filter will be applied, and I'll only load data from the filter that I've specified. Okay, let me go and hit finish and import that data. Okay, so that's completed. Right, so let's take a look at what it's actually done. So the tabular designer allows you to work against the actual data in your model. So it's a very interactive designer that lets you, see the data, make changes on the data, and see the results straight away. So I can look at the list of tables here, and I can start to do things like, filter and sort the data right here in the designer, so that I can actually, understand the data that's been brought in and, the effects as I change the model. I can also work against the model in a diagram mode, which is very useful for quite a lot of scenarios, such as, for example, figuring out the relationships between tables. So this diagram, I can zoom in and out and start to work with larger models. In this case, I can notice straight away that the training attendance and the employee tables have a relationship between them, and that was imported when I brought in the tables from the data warehouse because of referential integrity rules. When I look at the employee and position, I can see there's no relationship defined, but I want to create one. So I'm going to go and drag position key from the position table over to employee, and now I've defined the relationship between those two tables. So the diagram view is very handy for working with things where you need to think about the shape of your model rather than the data. Now, whether I'm working in diagram or working in the data view, I still have access to the property grid. So, for example, if I wanted to do things like rename the employee table to be employee rather than dim employee, I can use the property grid when I'm in diagram mode. And when I switch to data mode, the same property grid is available, so I can really choose where the right place is to work with the properties as I'm defining the model. Okay, so let's take a look at what's actually being brought in and how we'd like to extend this model. So the first thing is I see that the employee table has a lot of great information in it, but it has first name and last name as two separate columns, and what I really want in my model is a single column that has the employee's full name in it. So as part of the BI semantic model, I can create calculated columns that let me use the data analysis expressions or DAX language to add additional columns to the model to supply more sophisticated calculations. So in my column, I'm going to go ahead and say equals, and to specify a DAX expression, and then choose first name. In this case, it's a very simple expression. It's just concatenating the first name with a space and then a last name. Just hit enter. And as you can see, I'm working against the data here. So as soon as I've made that calculation, I can figure out what the results are without having to define a calculation and then deploy a model and then go and test it somewhere else. So you'll notice it's been named as calculated column 1. I can name it something else like full name. And there you can see how you can go ahead and add columns to the data that's been imported to build a more sophisticated model. There's a wide range of DAX expressions that you can use here. It's a very full-fledged formula language, and there's a lot of material available with the SQL Server 2012 launch on the DAX expression language. Okay, so let's take a look at some of the other operations I can do in the data grid. I'll switch to the date table, and I can see, for example, the date business key column is showing the time format as well. And really what I want to do is just make that short date, so I can change the format of these columns. So this is the kind of process you'll go through as you're building a BI semantic model. You'll take the data that's come in from the source system, you'll rename some things, you'll add some things to mark it up, you'll change formats and names and things like that in order to build a model that really is a great experience for the end users. So there I've gone and formatted the date column. I can also do other things like, for example, the month column. It's quite handy for calculations, but I don't really want to show that directly to end users, so I can go and hide that from client tools. So I can have columns in my model that are used for calculations and relationships, but that aren't necessarily shown to end users. Okay, so the model's starting to look pretty interesting. Let's start looking at some of the business logic that I'd like to add to this. So I have a training attendance table, and that shows me for every employee that's been on a training course what the result was and what the score was. So individual scores are interesting, but what I'm really interested in is to look at things like average scores. So what I'm going to do is define what we call a measure. So a measure allows you to do complex calculations across data rather than being a single column that just uses the current row context. So what I'll do is go into the measure grid and just start typing. I'll hit equals to start a DAX expression and then say max of the score column. Actually, in this case, I really don't want the max. Let me just look for average rather. I can do average of score and hit enter. And what it's done there is it's actually created a measure in this model, and it's showing me the results for that measure of all of the data that's currently shown in the grid. If I go and filter the view here so that I only show, for example, a specific training course, it will update the measure so that it's only showing the filtered values rather than the whole set. You'll notice that it named it measure 1 because I didn't specify a name. So I can either edit it in the expression itself or use the measure grid to go and change that to something like average score. Okay, so averages are interesting. Let me clear the filter. Averages are interesting, but there are other kinds of business logic I'd like to add here too. So for example, I want to add the max score, equals the max of score, and I'm probably going to need the min score for some scenarios as well. There's a shortcut to some of the more simple calculations that I showed called AutoSum, where I can just go and choose and say min, and it will automatically write the formula for me. So I can just change the title here. Okay, the measure grid that I'm working against as well is free form, so I can choose to arrange the measures in it in whatever shape I'd like. So let's say I have a new section here, which is I want to define a bunch of counts. I can put in a text or caption in the grid, or counts, and then just start adding additional measures here, like count, or in this case, distinct count of my employees. So it really lets you have a very free format approach to defining your measures. This is going to be employee count. All right, great. So I've defined some of these measures. I've got a very interesting model. So at this point, I'd really like to start testing it out and see what the effects are in client tools. What we've done is we've actually supplied a button in the designer itself that lets you launch Excel and connects to the model that I'm building. Now, what's actually happening here is that because the designer that I'm using here is working against data, behind the scenes there is actually an analysis services database created called a workspace database, which is driving this model. So as I'm using this and as I'm defining these measures, that workspace database is going to be updated and kept in sync with the designer. So if I go over to SQL Server Management Studio and show the list here, there you can see the project name. There's the workspace database, and if I have a look, there are all the tables. And so as I'm working with this model, that workspace database is kept up to date, and I can use that in other tools. So if I go back to Visual Studio and just launch Excel here, it lets me open up an Excel instance against the same model. And I can keep both open. I can run in Excel and in Visual Studio at the same time. So there's the model that I'm building, so let's go and try it out. So we had that average score. Let's go and put position in as well. Okay, so one thing straight away that jumps out is that it would be really nice if the average score was formatted with 2 decimals. I could change that in Excel, but then all the users would have to do that. So let me switch back to SQL Server Data Tools and change it directly in the designer. So let me choose decimal number here. And without any further changes, I can just switch back to Excel and refresh. And as you can see, it's working against the live model. So it's a very easy way to interactively change the model as I'm using it and testing it in Excel. Now, the next thing I notice is that average score is not a very interesting display at the moment. It's just showing the number of average score for each of these different positions. So what I'd rather have is something more like a key performance indicator that showed how the different groups were doing against their targets. So go back to the model and say, take that average score measure and create a key performance indicator from it. So what I can do is either choose a target value like another measure. Let's say I wanted to see the average as a percentage of the maximum, or I can define an absolute value, like in my case I'll just choose 100 and see how the score is doing against that value. I have a way of defining the thresholds here where I can say, okay, up to below 50 is red, between 50 and 80 is yellow, and above 80 is green. And I can choose a range of icon styles for when people are in a different position. let me just choose that. And so now that measure is turned into a key performance indicator. And if I switch over to Excel and refresh, now I can see a KPI in my Excel client. And so now, as well as just choosing the value, I can also choose the status here, which will show me an indicator of red, green, or yellow, depending on the score. And this KPI, just like all measures, works at all levels of granularity. So I can pick the employee table and choose that full name column that I added earlier, and now I can see how the average scores are doing across all those people. Okay, so it's a pretty interesting report I have already, and because I'm in Excel, I can do a lot of other things, like, for example, add slices. So let me go ahead and pick training categories and the training results and put slices into this as well. And so no matter how I slice this data, pick a particular category or whatever, the key performance indicators and measures are showing the results of those calculations dependent on the slices and the rows and columns that have been defined. Okay, so the model's looking pretty good at the moment. I'm pretty happy with how that's turning out, and I think users are going to get a lot of value out of it. But I'm going to need to define some of the more technical details of the model in terms of how it's stored and how it's secured. So the first thing I'll do is look at partitions. A table, as it comes in, is brought in as one large table, and if I refresh it, I refresh all the data in that table. For some of the larger fact tables or larger transaction tables that I have, instead of having one large table, I'd like to split that up in order to manage the process of refreshing that data. So I'm going to go ahead and choose partitions. And as I can see here, the training attendance table was brought in with a single partition. It's a very small data set at this point. It's only 862 rows. I filtered it on the way in when I imported it, so that the first partition actually is filtered to say only numbers that are less than 1,000. Let me switch to the SQL view to show that a bit more clearly. So there you can see the query that is actually driving this. Now what I can do is create multiple partitions so that I can refresh them separately. So I'll just copy the existing one and say, okay, for this partition, I'm going to show all the other data where it's greater than equal to. So the partitioning schemes that people can use here, you can partition across dates or times or other categories or geographical regions, whatever makes sense for your business process. So now that I've defined those two partitions, let me hit OK and actually process them. As I've created the partitions, they have no data in them yet, so I can say process partitions. Since the first partition was already processed when I imported it, I can just process the new one I've added and click on OK, which will prompt me for my credentials. And now I have the other 138 rows, so now I can see that my total set that I'm working against in this table is now looking at both the rows that are less than 1,000 and greater than equal to 1,000, because the table has the union of all the rows that are in the different partitions. These partitions will really let me manage it much more easily. The next thing I'd like to do is define security. So I'm going to go ahead and build security roles into my model. So the first role that I'd like is for administrators. Let's just call this admin. And the permissions that people in this role have are to administer the database. As I'm defining this, I could go and define members of these roles right now, but typically what I do is build the roles as part of the model and then deploy it, and then in Management Studio I would go ahead and add members to that. So that's the admin. The other thing I'm going to do is put in users and say, okay, users don't have administrator rights, but they do have rights to read the data. Okay. Now, one interesting thing about this database is that in the model I have data for multiple levels in the organization, going up to the chief of police. And what I'd like to do is actually do row level security so that I can actually define a role that filters the data so that users who are managers can see all of the training results, but users that are below that level can only see data, for example, up until position level 4 here and above. So let me go back to my security dialog and make that change. So I'll say users. I'll define a DAX filter that filters the position table to say, okay, the dim position sequence key has to be greater than 3 for this user to be able to see it. So this user won't be able to see chief of police or deputy police. They'll be able to see everyone below that. And I'll also define a manager's role that can actually read everything, that has no filter defined. Okay, so there's my security scheme for this model. I have administrators, I have users who can read everything for employees above a certain level, and I have managers who can read everything. Now, the first thing I'm going to want to do here is actually test that out. So when I go and launch Excel, it will prompt me and let me specify either a specific user or a role that I've defined in order to test it out. So let me see what the effect is for users. Click on OK. Now we'll launch Excel as the user role that I defined there. So let me pick the average score or the employee count and show that the positions is filtered. Okay, so now I can see, if I showed the sequence here, I can only see anything with sequence above 3, and because the row level security is defined, it's also filtered out all the related rows that go along with that. So I haven't just filtered the position table, I've also filtered the employee table, which is connected to the position table. All right, so the row level security that we have will actually filter out all the data that the user is not allowed to see beyond the current table as well, into related tables. Okay, so my model now has a pretty interesting model. It has the security defined, it has partitions set up to administer it. The last thing I'm going to do before I deploy is look at some of the properties that are specifically designed to improve the Power View experience that users have when connecting to the model. So if I go to the employee table, I can see here the columns I've defined and the properties that have been specified. There is a section in the table properties that lets you define reporting properties that affect the Power View experience and other client tools that will use this. So the first thing is I can say, what is the default field set? And what this means is that if an end user double-clicks the employee table in Power View, what is the set of columns that will be displayed by default? And in this case, I'm going to want it to be the full name as well as the phone number and the email address of the user, rather than all the other ones. Okay, so once I've built that, added that property to the table, that will control the experience in Power View. If I needed more sophisticated control over the Power View experience, I can use the table behavior dialog. What this does is it allows me to define things like a primary key or row identifier for the table, in this case we'll use the employee key, and it lets me specify behavior for columns that you would like to keep unique. As an example of this, if I have 2 employees with the same full name, like John Hancock, if I drag the full name column onto the canvas in Power View, it should always keep those 2 rows separate. Right? It should never collapse 2 employees with the same name into one row. And by defining this property in the model, that will actually control that behavior. I can also define which column in this table I would like to be the default label, and this affects experiences such as the card view in Power View, where you by default will show the employee's full name on top of the card. If I had images defined in this model, I could do the same thing for image, which would control the image that's displayed on the card by default. Okay, so my model is exactly how I'd like it now. The next step I need to do is deploy that to a server. So I'll look at the project properties, and by default it's putting my deployment server as localhost, which is the same one I'm using for my workspace database. I'm going to name the database here, Academy Demo. I can change the name of the cube if I'd like. I'm just going to leave that at model for the moment. And I can also choose some of the options for this model, like changing the processing option to do not process. What I'd like here is that when I deploy this model, I only deploy the metadata and don't actually physically process the data until later. So I'll hit on OK. and then go to debug, build, and deploy the solution. So what it's doing now is it's connecting to that analysis services server instance running in tabular mode and deploying the model that I built here in SQL Server Data Tools. Okay, so switching over now to the administration experience, what I have here is SQL Server Management Studio connected to that instance, and I'll just refresh to show the latest one that's been deployed. So there I can see the workspace database that was loaded, and I can also see since I deployed it to the same server, I can see the final model that I've deployed for end users to connect to. Now, because I chose not to process this, there's no data loaded in the model yet. So the first thing I'll do in Management Studio is go ahead and process the database to load the data into it. Okay, so that's successful. Now I'll just browse the database just to check that it's all working. So the Cube browser or model browser lets me from within Management Studio just go and test out to see whether the data that I'm expecting has been loaded correctly into the model. So let me just pull in some of the dimensions and measures in here. And as you can see, this is another example of the BI semantic model in action. The Cube or model browser is showing a very multi-dimensional view of the model in terms of breaking it out into measures and dimensions and what have you. Whereas if I connected Power View to the same model, it would actually show tables like I originally defined in the Tabular Designer. Great, so there's a couple of things I can do in Management Studio. I can also look and define partitions. So even after I've deployed the model to the server, I can go and define the partitions and modify them from Management Studio. I can also use processing so that I can define processing on, have a lot more control on partitions. I can use scripting. I can do all of the features that you'd expect in Management Studio for managing the partitions and the processing of them. And finally, the last thing I can do in Management Studio is I can define further roles or manage the ones that are in there already. So let me go and choose the user's role that I defined already. Look at the properties, and here I can see the role name. I can see that it's defined as a read role, as I did in SQL Server Data Tools. And now this is the point when I'd actually go and define the members of this role. And in this case, I'm going to use an individual user, but I could, of course, here also use groups so that I could define an authorization group and then just add that to the role. Okay, so there you have it. That's the experience for managing the model that I've deployed using the SQL Server Management tools. Okay, so that ends today's session. Thank you for attending.